Two roads, one running north-south and the other running east-west, meet at a point A. Well, let's draw that situation. At 12 noon, Tommy is 30 kilometers east of A and driving at 60 kilometers due west. So let's say that Tommy is here, and initially this is 30 kilometers, and he's traveling this way at 60 kilometers per hour. Romeo is 20 kilometers south of A. So Romeo is here and driving at 80 kilometers per hour due north. So he is going this way at 80 kilometers per hour. What is the shortest distance between them and the time at which this happens? Well, the distance between them is the third side of this triangle. So we'll call that D. Now think about Tommy's distance from A. It's going to be 30, take away 60t. So when t is 0, he's 30 kilometers from A, and we know that's the case, that's in the question. And let's say that t was 0.5, he would then be at A. Half an hour at 60 kilometers per hour would cover that 30 kilometers. So if we look at that triangle, where this is A, this is T, and this is R, this side would be 30, take away 60t. Arguing exactly the same way, this side would be 20 minus 80t, and therefore D, or D squared, would be 30 minus 60t squared plus 20 minus 80t squared. We want to minimize D, and if we minimize D, we're going to minimize D squared. So we're looking to minimize this. So we can differentiate using the chain rule here. So D squared dt would be twice 30 minus 60t to the power 1 times negative 60 plus twice 20 minus 80t times negative 80. So that's going to be negative 120, 30 minus 60t, take away 160, 20 minus 80t. And since we want d squared dt to be equal to 0, that means, now note, those are both negative, so we can easily make them both positive if we're putting it equal to 0. So I've got 120, 30 minus 60t, plus 160, 20 minus 80t is equal to 0. Now both of these brackets have a common factor that can be taken out. In the first case, we could take out a factor of 30. And so that would be 3,600 into 1 take 2t. For this bracket, it's a 20 that can be taken out. So that would be 3,200, 1 minus 40, and all of that is equal to 0. Okay, well, we can divide through here by 100. And then we could divide through by 4, giving us 9, 1 minus 2t, plus 8, 1 minus 4t, is equal to 0. So that's 9 take away 18t plus 8 take away 32t is equal to 0. And that gives us 17 minus 50t is equal to 0. So t is going to be 17 over 50. Now we know that t is in hours. So if we want to turn that into minutes, let's do 17 over 50 times 60, and that is 20.4 minutes. And so the first thing we want to know is d min. We also wanted to know the time at which that happened, and they started off at noon, so at 12 noon. So the minimum d is going to happen when the time is 12:20. That's 20.4 minutes. And we could, if we want, right here, and if we did 0.4 times 60 and 24 seconds, put that in brackets, and the d minimum, well, let's go back and evaluate d squared using our value of t. So I'm going to put in the calculator here 17 over 50 and press equals, and then it's my last answer. And then I can do 30 take away 60 times the answer squared plus, open the bracket, 20 take away 80 times my last answer squared, and that is 144. And so if d squared equals 144, then the minimum would be 12 kilometers. 12 is the square root of 144.